Hello and welcome to Math with Mrs. Becker. Today in Algebra 2, we are going to do the very first part of section 6.5. Now 6.5, we get pretty in depth with finding the roots. Remember, those are the zeros of polynomial functions. In fact, if you notice, we actually spend 4 days on one section because I really just want to make sure that you understand how everything works. Okay. In section 6.4, we did use several methods for factoring polynomials. Now, factoring is something that hopefully you covered back in Algebra 1. We looked at again in Chapter 5. We revisited some of those techniques in 6.4. Okay, as with some quadratic functions, factoring a polynomial is one method, and typically it's the quickest method that we can find real roots. So that's what we are going to do today. We are going to use those factoring techniques that we have covered previously in this course, along with the zero product property to find the zeros. Remember, when you are looking at zeros, you take your polynomial function and you set it equal to 0. Then you go ahead and you factor. Once it's factored, you set each factor separately equal to 0 and you solve the equation. So we will go ahead and try a few of these. The difference is going to be, look at the degree of this thing. This has a degree of 6. Before, when we have factored, at least back in Chapter 5, the highest degree that we had was a 2. Okay, but just kind of showing you that we'll be looking at the same types of techniques. Step 1, when you are factoring, you always want to look and see if all of your terms have something in common that you can divide out. In this case, 4, 4, and negative 24, they are all divisible by 4. Now, if I look at the x's, this term has 6 x's, this has 5, and this has 4. So I am able to remove 4 x's from each group. So what you do is I put the 4x to the power of 4 on the outside. Whatever they have in common goes on the outside. To figure out what goes in the parentheses, we go ahead and divide. 4 divided by 4. If I have 6 x's and I take 4 out, I'm down to 2. Plus sign. 4 cancels 4. I have 5 x's. If I take 4 out, I'm down to 1. Minus sign. 24 divided by 4 is 6. If I have 4 x's, I take them out and they're gone. Now, this was 6.4. You factor and you look and you say, what can I do now? 1, 2, 3 terms. Remember from Chapter 5, if you have 3 terms, that's our multiply-add method. There is not a number in front of the squared term. So we are looking for 2 numbers that if I multiply, I get a negative 6. If I add, I get a 1. That would be positive 3 and negative 2, because 3 times negative 2 is negative 6. 3 minus 2 is 1. So I can factor this further. It's x plus 3, because the 3 is positive, x minus 2, because the 2 is negative. Now, if I want to find my zeros, I have to take each factor. Each factor means each separate piece. So 4x to the power of 4, that's one piece. I set that equal to 0. X plus 3, that is a piece. X minus 2, that is a piece. Now what I need to do is solve for these. So if I divide both sides by 4 here, the 4's cancel. So I have x to the power of 4. 0 divided by 4 is 0. To get rid of a 4th root, or a power of 4, you take the 4th root. What number times itself 4 times gets you to 0? That's a 0. Here I minus a 3. X equals negative 3. Here I add a 2. X equals 2. So when I graph this, and we are going to go ahead and go on to Desmos.com just to check our answers. When I graph this function, my graph should either touch or cross the x-axis at 0, negative 3, and 2. So let's go into Desmos and let's graph this. 4x to the power of 6 plus 4x to the power of 5 minus 24x to the power of 4. Here is my graph. Now what I want to do is I'm just looking at the zeros, okay? So if I go ahead and I tap, I can see the zeros. We should have our solutions at negative 3. Yep, we have a negative 3. 0. Yep. and 2. Notice for all of these ordered pairs, the y value is a 0. That's often why they are called zeros, because at an x-intercept, where your graph touches the x value or the x-axis, your y value is always going to be 0 because you're not traveling upwards or downwards. Okay, let's go to the next one. Very similar. If I look here, step 1, you want to see, is there something I can divide out of 2x to the power of 6 minus 10x to the power of 5 minus 12x to the power of 4? I can divide 2, 10, and 12 all by a 2, and I also notice that they all have an x. This has 6 x's, this has 5, this has 4, so I can actually remove 4 x's from each term. To figure out what goes on the inside, you divide each number by 2, and you remove 4 x's. 2 cancels a 2. If I have 6 x's and I remove 4, I'm down to 2. Minus 10 divided by 2 is 5. 5 x's, take 4 out, I'm down to 1. Minus 12 divided by 2 is 6. If I have 4 x's and I take them all out, they're gone. So I factored. Now we want to be in the habit of looking and saying, now what can I do? 1, 2, 3 terms. 3 terms is the multiply add method. There is not a number in the front of my squared term. I want to find 2 numbers that multiply to negative 6, the same numbers add to negative 5. That would be negative 6 and positive 1. Negative 6 times positive 1 is negative 6. Negative 6 plus 1 is negative 5. So factored further, I still have my 2x to the power of 4 out front. The 6 is negative, so it's x minus 6. The 1 is positive, so it's x plus 1. So this is factored. Now to find the zeros, you take each piece separately. 2x to the power of 4, that's set equal to 0. X minus 6, that's set equal to 0. X plus 1, that's set equal to 0. Now what I need to do is solve each equation. So here if I divide by a 2, 0 divided by 2 is 0. To cancel an exponent of 4, you need a fourth root. What number times itself 4 times gets you to 0? Well, that's a 0. Here I add a 6. 0 plus 6 is 6. Here I minus a 1. 0 minus 1 is negative 1. So my zeros, when I graph this on Desmos, that polynomial function would touch or cross the x-axis at 0, 6, and negative 1. So let's go on to Desmos and let's see if that's the case. 2x to the power of 6 minus 10x to the power of 5 minus 12x to the power of 4. Here is my function. I want to check my solutions, so I go ahead and tap on the zeros. We are looking at the x values. My x value should be negative 1, yep, positive 6, yep, and 0. So we used Desmos to make sure that we were on the right track. All right, 2 more questions. When you are trying to find zeros, you want your polynomial set equal to 0. So this problem, I need to move that 26x squared over to the other side. And remember, when you're factoring, it's important to have things in standard form. So this has the most amount of the x's. That's why x to the power of 4 comes first. When I subtract this 26x squared to the other side, it would go in between x to the power of 4 and 25, because now I have 4 x's, 2 x's, no x's. Here's a really cool trick. If your exponents are 4, 2, and 0, you still do the multiply add method. There is not a number in the front, so I need 2 numbers that multiply to 25. The same 2 numbers add to negative 26. Well, my friends, that's going to be negative 1 and negative 25. Negative 1 times negative 25 is positive 25. Negative 1 minus 25 is a negative 26. Because the exponents are 2, 4, and 0 instead of 2, 1, and 0, you have x squared with the numbers. So x squared minus 1 and x squared minus 25. We have twice the amount of x's when I'm looking at the exponents. So in the factors, you have twice the amount of x's as well. Because if I remember, when you're factoring, it's kind of like foiling backwards. If I take first times first, x squared times x squared is x to the power of 4. You need to make sure that if you multiply the first two terms, you end up back to the original first term. Okay, so again, same method, multiply, add. Because it's 4, 2, 0, that's why they have a power of 2. Now look at this, we have the difference of squares. Two terms with a minus in between. I can take the square root of x squared, I get an x. I can take the square root of 1, I get a 1. I take the x and the 1 and you add them and you subtract them. I can do the same thing here. Square root of x squared is x. Square root of 25 is 5. I take the x and the 5 and I add them and I subtract them. Now what I need to do is take each piece separately, set it equal to 0. So x plus 1 equals 0. X minus 1 equals 0. X plus 5 equals 0. X minus 5 equals 0. Last step, solve each equation. So here I would minus 1. 0 minus 1 is negative 1. Here I would add 1. 0 plus 1 is 1. Here I would minus 1. Minus 5. 0 minus 5 is negative 5. Here I would add 5. 0 plus 5 is 5. So when I go ahead and I graph this, and we're going to graph it in the format once we got it set equal to 0. So when I put x to the power of 4 minus 26x squared plus 25 into decimals, I'm going to see a graph that crosses or touches the x-axis at -1, +1, -5, and +5. So let's check it out and make sure that that's what we get. X to the power of 4 minus 26x to the power of 2 plus 25. Here is my function. Check that out. 1, 2, 3, 4 zeros. And you can go ahead and just tap. We are looking at the x values. Our solution should have been -5, -1, +1, +5. That's exactly what we got. So we checked our work. We have a visual of what's going on. And we can move on to the last question. Okay, if I'm trying to solve by factoring, you want to find the zeros. That means you need this thing equal to 0. So step 1, I need to take that minus 50 and I need to bop it on over to the other side. X cubed minus 2x squared minus 25x plus 50. It's negative on this side, so when I bop it on over, it's going to be adding. 1, 2, 3, 4 terms. Anytime you have 4 terms in your factoring, the process that you use is called grouping. The reason why it's called grouping is because you put parentheses around the first 2 terms, then you put parentheses around the second 2 terms. When I look at the first group, you want to see what they have in common. Both of those terms have 2 x's, so I can take 2 x's out. If I have 3 x's and I take 2 out, I'm down to 1. Minus 2, I had 2 x's, I take them both out. Okay, so I still have the -2. With grouping, I need this to match this. So often I think the easiest way to do that is to compare the first 2 terms. -25x is what I have. I need it to match a +1x. In order to do that, I need to divide out a -25. That way the negative cancels and the 25 cancels, leaving me with just an x, and that's what I want. Positive divided by a negative is a negative. 50 divided by 25 is 2. Once these match, you know without a doubt you did this correct. Whatever you took out, x squared minus 25, that comes together to form a group. The binomials that match, that is your second group. But again, we are at a level of math where, yes, we just factored, doesn't mean we're done. You look and you say, is there anything more I can do? And guess what, folks? There is. I have 2 terms with a minus in between. Square root of x squared is x. Square root of 25 is 5. I can take the x and the 5 and I add them and I subtract them. I still have my x minus 2. So now to find the zeros, you take each piece. X plus 5 equals 0. X minus 5 equals 0. X minus 2 equals 0. Here I minus 5. 0 minus 5 is -5. Here I add 5. 0 plus 5 is 5. Here I add 2. 0 plus 2 is 2. So what this tells me is when I go and put this into decimals, I am going to see a graph that touches or crosses the x-axis at 5 units to the left of the origin, 5 units to the right, and 2 units to the right. Let's check it out. X to the power of 3 minus 2x to the power of 2 minus 25x plus 50. I am just looking for intercepts. So here they are. When I go ahead and tap on those intercepts, I'm looking at the x value. My solution should have been -5, +2, +5. That's exactly what I got. And you guys, that is where we are going to stop for day 1, because I want you to really practice factoring, finding those zeros, and then please definitely take the time to check your solutions on Desmos. It'll just kind of make sure that you're on the right track. Your assignment for today is in the book. It's pages 442 and 443. You are going to do numbers 2 through 7, and then jump up and do 15 to 17. I hope you had a great time today, and I will talk to you soon.